The series summation 1 upon n raised to the power p converges if this is the structure summation 1 upon np, and this series is convergent when value of p is strictly greater than 1. For p less than equals to 1, this series always divergent, so option C will be correct. And this test is known as p series test. Normally, this type of series is known as p series, and this test is p series test.
If 1 minus 1 upon 3 plus 1 upon 5 minus 1 upon 7, we can collect these terms like this: 1 upon 9 minus 1 upon 11, and so on. And this value is equals to pi by 4. We have to evaluate the value of 1 upon 1 into 3 plus 1 upon 5 into 7 plus 1 upon 9 into 11, and so on. This one can be written as 1 upon 2 outside and within square bracket, 1 upon 1 minus 1 upon 3 in first round bracket, 1 upon 5 minus 1 upon 7 in second bracket, and so on. From the given value, we can write inside the bracket value as pi by 4. Now simplify this term, we will have pi upon 8. So which one option is giving you pi upon 8? Option A is correct answer.
Sum of this series 1 upon 1 into 2 minus 1 upon 2 into 3 plus 1 upon 3 into 4. I can write this series as 1 upon 1 minus 1 upon 2 minus 1 upon 2 minus 1 upon 3 plus 1 upon 3 minus 1 upon 4, and so on. Now collect the first terms of the brackets. So 1 upon 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4 plus 1 upon 5, and so on. And the second term of brackets. So minus 1 upon 2 plus 1 upon 3 minus 1 upon 4 plus 1 upon 5. If we add and subtract 1 from this series, this one, this value is log 2. So log 2 minus 1, and this value is log 2. So entire series we can write as log 2 plus log 2 minus 1. The value of this one can be written as 2 log 2 minus 1, and this is can be written as log 4 minus 1 using laws of algorithm. Option B is correct. Logarithm. Square matrix A is an invertible if and only if it is non-singular. Suppose this is a matrix A and this is invertible. If it is invertible and of this size n cross n, so rank of this matrix A equals to n because of invertible. Rank is same as size of the matrix. That's why each row and each column contain pivot element. It means that matrix A is 1 1 and on 2. So both condition together. But in option A only 1 1. That's why this is wrong. In option B on 2. That's why again wrong. 1 1 but not on 2. Option D discard, and none of these because 1 is true. So option E is a discard. So option C can be replaced as 1 1 and on 2. Then this option must be true.
In which matrix is singular, then its determinant is 0. So determinant x into x minus 1 minus 2 equals to 0. This is value of determinant. I can write x square minus x minus 2 equals to 0. X square minus 2x plus x minus 2 equals to 0. Factorize this. So take x as a common, x minus 2 and plus 1 x minus 2 equals to 0. Now we have x plus 1 into x minus 2 equals to 0, x equals to minus 1 or x equals to 2. Minus 1 is not given in in these options, that's why you cannot accept this, but x equals to 2 given in option C, that's why option C will be correct.
Suppose matrix M is given and this is upper triangular matrix where A1 and A2 are square matrices. The characteristic polynomial of M is the characteristic polynomial of A1 and A2. This question is a fill up type and there are five suggestions for us. So how to solve this problem? First, we try to identify which type of matrix it is. So A1 0 B A2. This is upper block diagonal matrix. It is upper block diagonal matrix, and in this case the characteristic polynomial we can find out easily with the help of characteristic polynomial of a1 into characteristic polynomial of a2, means the product of option B is correct. If u equals to log of x square upon y, then we have to find x partial u with respect to partial x plus y partial u with respect to partial y. And this one equals to x into y upon x square into 1 upon y to x plus y upon, sorry, it is okay, y upon x square into x square minus y square raised to the power minus 2. So what is this value? X square cancel out by this and y from y we have 2 minus y square cancel out from y square and x square from x square, so minus 1, so 2 minus 1 we are getting 1. Option B is correct. A function which have continuous first partial derivative on some rectangle R denoted by R. In this rectangle, all those points with satisfying x minus mod of x minus x naught less than equals to a and y minus y naught less than equals to b. Then the equation m is a function of xy plus n function of xy y prime equals to 0 is exact if and only if m y equals to nx. This is necessary and sufficient condition for an equation is exact. Option B is correct. You can write this equation as m is a function of xy dx plus n is a function of xy dy equals to 0. U is a function of x and y. U equals to sine inverse x over y plus tan inverse y over x. First partial u with respect to partial x, 1 upon under root of 1 minus x square upon y square into 1 upon y plus 1 upon under root 1 plus y square upon x square into y upon x square and take negative of it. Similarly, partial u with respect to partial y, this one is equals to 1 upon under root 1 minus x square upon y square into x over y square, take negative of it, plus 1 upon under root 1 plus x square. Sorry, please not take a, whenever we are dealing tan inverse, not take a square root. 1 upon 1 plus x square upon, sorry, y square upon x square into 1 upon x. We have to calculate x partial u with respect to partial x plus y partial u with respect to partial y. Now put the values, and what we have, x into 1 upon y into 1 upon under root 1 minus x square upon y square plus x into minus y upon x square 1 over 1 plus 1 plus y square upon x square plus y into minus x upon y square into 1 upon under root 1 minus x square upon y square plus y over x into 1 upon 1 plus y square upon x square. Now this x cancel 1x, and this is minus y over x into 1 over 1 plus y square upon x square, and the last term is y over x into 1 over 1 plus y square upon x square. This term will cancel out because of alternate sign. Similarly, these two terms. So entire value goes to 0. Now, which one option is giving you value 0? Option D is correct. The necessary condition for a function capital F of xy to have an extreme at AB. If a function in two variable have a extremum, then fx means a partial derivative of f with respect to x at AB, and partial derivative of f with respect to y, both will be 0. It means option C is correct. The particular integral of the equation d square minus 4d plus 3y equals to sine 3x. To find a particular integral, so denoted by pi equals to 1 upon fd into sine 3x. We have to replace the d square by minus 3 square. So what we have? We have 1 upon d square minus 4d, d square minus 4d plus 3. This is our equation, and this is sine 3x. This one equals to, after replacing, we have 1 upon minus 9 minus 4d plus 3 sine 3x. This one equals to minus 1 upon, or 4d plus 6 sine 3x. Actually, we need to convert this d into d square, so we can replace d square by minus 3 square. For this, minus 1 upon 4d plus 6 into 4d minus 6 upon 4d minus 6 into sine 3x. This one equals to minus 1 upon 16d square minus 36,
and this is within bracket 4d minus 6 sine 3x. Now we have minus 1 upon minus 16 into 9 minus 36 within bracket 4d minus 6 into sine 3x. Now minus 1 upon minus 180 within bracket 4 into 3 cos 3x minus 6 sine 3x. Now take common. So 2 cos 3x minus sine 3x upon 30. Which one option is matching? 1 upon 30, 2 cos 3x minus sine 3x. Option D is correct. Z equals to function of xy, where x equals to eu plus e raised to the power minus v, and y equals to e raised to the power minus u minus e raised to the power v. Then we have to find partial z with respect to u, and this one equals to partial z with respect to x and partial x with respect to u. How? Z is a function of xy, z is a function of xy, and x and y both are function of u and v. That's why partial z with respect to u equals to partial z with respect to x into partial x with respect to u plus partial z with respect to y and partial y with respect to partial u. This value equals to partial z with respect to x and partial x with respect to u will be e raised to the power u plus partial z with respect to y into minus e raised to the power minus u. Now try to find partial z with respect to v. This one equals to partial z with respect to x and partial x with respect to v plus partial z with respect to y, partial y with respect to v. This one equals to partial z with respect to partial x into minus e raised to the power minus v plus partial z with respect to y into minus e raised to the power v. Now partial z with respect to u minus partial z with respect to v equals to partial z partial x e raised to the power u minus partial z partial y e raised to the power minus u minus of, now minus minus turns to positive, so partial z with respect to partial x e raised to the power minus v plus partial z with respect to partial y e raised to the power v. What we have? Now try to collect these two. Partial z with respect to partial x e raised to the power u plus e raised to the power minus v, and take minus partial z with respect to partial y e raised to the power minus u minus e raised to the power v. Now this value equals to x partial z with respect to partial x minus y partial z with respect to partial y. Now which one option is giving this value? Option D is correct one. Sorry, not option D, option E. It is given fx equals to f 2a minus x, and we have to find integral from 0 to 2a fx dx. This value is same as 0 to a fx plus f2a minus x dx. If this f2a minus x is equals to fx, and this is same as, so fx plus fx from 0 to a, this value is same as equals to 2 times 0 to a fx dx. So option D is correct. The value of the definite integral from minus a to a mod x dx. If this integrand function is even, then value of this integral is 2 times 0 to a integrand function dx. So this one equals to 2 times 0 to a mod x dx, because limit is from 0 to a and value of a is positive, so mod function is same as x. So we can write 2 times 0 to a x dx, and this is same as x square from 0 to a, and this value is equals to a square. Option D is correct. Integral from 0 to pi by 2 sin raised to the power 4x cos raised to the power 2x dx equals to 1 upon 2 gamma 4 plus 1 by 2 gamma 2 plus 1 by 2 divided by 2 times gamma this value plus this value, means 5 upon 2 plus 3 upon 2. This value is same as gamma 5 upon 2, this is gamma 5 upon 2, gamma 3 upon 2 divided by 2 times gamma 4. Now this value, if gamma n and n is rational, then n minus 1 gamma n minus 1. So 3 upon 2 into 1 upon 2 gamma half, and gamma half is root pi. Similarly, 1 upon 2 into root pi divided by 2 times gamma n when n is integer equals to n minus 1 factorial. So 3 into 2. What we have? Pi upon 32. Pi upon 32 is given in option C. That's why option C is correct. The equation, this is differential equation cos x minus x cos y dy equals to sin y plus y sin x dx is. So we need to try mdx plus ndy. First we try to write this equation in this format equals to 0. So sin y plus y sin x dx minus, or you can put to positive, so minus cos x plus x cos y dy equals to 0. Now this is m and this is n. Now try to check this equation is exact or not. For this, partial m with respect to y and partial n with respect to x should be same. Now cos y plus sin x, this is partial m with respect to y, and partial n with respect to x will be sin x plus cos y. Both are same, so equation is exact. Now try to find the solution of this integration of m plus integration of n, only those terms containing or free from x, or you can say independent from x. So cos y, integrate m with respect to x, so sorry, integrate m with respect to x plus integrate n with respect to y. So this solution can be easily written as sin y, or x into sin y, plus y cos x, and derivative of sin y, sorry, derivative of sin is negative, so negative minus y cos x, and both term are not free, so this is only solution. X sin y minus y cos x, y cos x, y cos x, so you can write y cos x minus x sin y equals to c. So y cos x minus x sin y equals to c. Option B is correct. Let G be an infinite cyclic group, then G possesses infinite number of generator. Not possible. Exactly one generator. If G is cyclic infinite group, then infinite group, if A is generator of this, if A is generator of this, then A inverse also generator of group G. So there are two generators, exactly two generator. Option C is correct. Let G be a cyclic group of order 8, then number of generator of G you can find easily with the help of Euler-Phi function. So value of phi 8 equals to phi 2 cube, and we can write 2 cube into 1 minus 1 upon 2. This value is 8 into 1 upon 2 equals to 4. Option D is correct.